to acknowledge that Comcast Channel 17 is here and they're videotaping this session for later air date, and they'll tell us when that's going to happen. How many of you are amateur radio operators? Show of hands. Very good, very good, very good. How many of you are from the public? Show of hands. Really nice, really nice. Any firefighters? Police officers? Good, good. EMS? Randy, put your hand down. Any other organizations? Red Cross? I apologize if I missed anybody, but it's good to see you here. This is the first for Genesee County of this year for the SkyWarn Spotters Training. This class will repeat for the general public on April the 14th at 7 p.m. right here in the same auditorium. It's a repeat. You're welcome to attend. Tell your friends and neighbors and family and whatever, they're welcome to attend. It's free. Everybody is familiar with tornado awareness. Everybody's familiar with thunderstorms. Let me give a little intro about what the Amateur Radio Emergency Service at Genesee County does. We go out into the field when the National Weather Service issues a tornado watch or a thunderstorm watch, and some of the stuff you're going to see on the slides here is what we spot for. And what we do is we communicate that through a network of radio communications into a state network which goes right directly to the Weather Bureau. And once the Weather Bureau gets the information, they disseminate what we see here or whatever and decide if the issuance of severe weather warnings or tornado warnings are imminent at that time. And I'm sure Karen here will explain all that.
Oh, yeah.
So, without further ado, I'd like to introduce Karen Clark of the National Weather Service out of Detroit, Pontiac.
All right, thank you very much. All right, well, I definitely want to thank all of you for taking some time out of your Saturday morning to come out and learn a little bit about the weather and to volunteer to be weather spotters. You guys really do provide a very valuable service to us and really help us to improve the whole warning process, and we'll talk about that here in a few minutes. So I just really do want to thank everybody for taking the time to come out here, and hopefully we've got a good presentation for you. It's been updated again this year. Lots of new pictures, new videos, and things like that to keep you interested. So it does run about probably about 2 hours and 15 minutes, and we'll take about a 10 or 15 minute break there in the middle so you guys can get up and stretch a little bit. Heard some of you were up last night on a fire, so hopefully I don't see too many of you snoozing, but if you do, I understand. All right, so there were a couple handouts to pick up out in the hallway. Also a sign-in sheet, so please make sure you do get a chance to sign in. If you haven't done so already, you can do that at the break. There is also a severe weather spotter reference guide, and this is going to be something that's going to have all of the information about what we want you to report to us on there, so please make sure you pick up one of these. There is a nifty pocket card that has all the same information on there and our 1-800 number. So you can take this, stick it in your wallet, and that way if you don't have the flyer at home, you can pull this out and still see what it is that you need to report to us. And then lastly, we have one of these nice glossy guides, basic weather spotting guide. This has a lot of good pictures about all the things we're going to be talking about today. So I have these up here at the front. If you didn't get a chance to grab one, you can come up and get one during the break. This brochure has not changed, though, over the last couple of years. So just to help us save on the printing costs, if you have one of these at home that you know where it is, then maybe you skip picking one up today. Or if you're here with your family, maybe you only pick up one copy of the nice glossy brochure. So as we go along, please let me know if you have any questions, and I'll try to answer those the best I can. And all right, I think we'll go ahead and get started. Okay, in the first half here, we're going to talk about thunderstorm hazards, some different weather references, how to stay in touch with the weather, how to make sure you know what's coming, what to expect, weather safety, and then finish up with what to report and how we want you to actually report that to us. All right, so starting off, there are about 125 different National Weather Service offices across the whole United States. Here in Michigan, we have 4 offices. There's one, our office is located in the Detroit-Pontiac area. We cover Southeast Michigan. There's another office over in Grand Rapids, one up in Gaylord, and one up in Marquette in the Upper Peninsula. And the National Weather Services are spaced off with covering an area of responsibility. Our area of responsibility is the 17 counties in Southeast Michigan, extending from the Ohio border up through the Saginaw Valley and through the Thumb. We also issue forecasts and warnings for Lake Huron, Lake St. Clair, Detroit River, St. Clair River, and portions of Lake Erie. Okay, so for the National Weather Service, and we're the ones that have access to all this high-tech radar, satellite equipment, all of those things, then why is it that we need you guys to come out on your Saturday morning and learn about the weather? Well, there's a lot of things that our weather spotters can tell us that we may not be able to figure out while we're sitting in our office. People think that we know exactly what's going on across the area just because we have access to those tools. But we really don't have a lot of sensors out there that can actually tell us what's going on at the surface. The things that we're seeing on our radar are actually things that are going on up in the sky, up 3,000 feet, 4,000 feet, and higher, up to maybe 20 or 30,000 feet or more. And so we're looking at what's going on in the clouds. And so by looking at that radar, the things that we can identify on there are things like if a thunderstorm's strengthening or not. And we can tell if there's hail forming in that thunderstorm. But what we don't know for sure is maybe how big that hail actually is by the time it gets down to the ground. Is that hailstorm producing a whole bunch of really tiny, small pea-sized hail? Or is it starting to produce some larger, maybe golf ball size hails, but just a few of them? And so those are the types of things that our weather spotters can tell us from being down on the ground and telling us what's going on underneath that thunderstorm. And so the way this whole process works is that we're looking at the radar, we're looking at what's going on in the environment before the storms ever develop, and then we're listening to all those reports that we get in from our spotters to try to determine if we need to issue a severe thunderstorm warning, if we need to issue a tornado warning, or some type of a flash flood warning. All right, so all that information comes into our office at the National Weather Service. We send that out to the media, over the radio, over the television broadcasts, and that goes out to you guys and to the rest of your community once we do issue those warnings. And that gives people the time to act and to respond and to hopefully be safe before those thunderstorms ever reach their area. All right, and this actually makes this year marks the 50th anniversary of the SkyWarn program. And so we are really proud to have this program and have it in service for this long. And I can tell you that over the last 50 years, the improvement that we have seen to the whole warning process has really been tremendous. And so we really do thank all of you guys for being a part of this program, and it really does help us out in the job we're trying to do tremendously. Okay, so got a few statistics up here on the chart, and some of the things that you'll see up on here was that this was our first year with storm-based warnings, and we're going to talk about that a little bit here in a few minutes. But what we also have up here are all these statistics about how good of a job we did last year, basically. And this is something that we keep track of very closely. We're part of the federal government, and we're kind of held accountable for how well we're doing. And so every time that we go out and we issue one of these severe thunderstorm warnings or tornado warnings, we have to try to figure out if that was a good warning or not. And the primary way that we figure that out is through getting those spotter reports in from all of you guys. And so if nobody calls in and tells us that they saw tree limbs down, or they saw large hail, or they saw, or they observed really strong winds, then we don't know, and that warning kind of counts against us. But if somebody calls in a report to us and tells us, I did see a tree down in my neighbor's yard, then that lets us know that we did a good job and we issued a good warning. And so I'm just going to run through a few numbers up here on the screen. First off, we had issued 139 warnings last year. Out of 139 warnings, 102 of those warnings verified, meaning that severe weather did occur while the warning was in effect. And you can see that 37 of those warnings did not verify, meaning that 37 times we issued a warning and nothing ended up happening, or nothing was reported back to us. And then I'm going to skip down here to the end and show you the numbers on the lead time. And what the lead time is the amount of time from when we actually issued the warning to when the first severe weather, or when the severe weather actually occurred in the county, or in the area where the warning was in effect. And so, on average, you can see that the lead time for last year was right around 23 minutes, meaning that's the amount of time that people had to respond between the time we issued that warning and when the severe weather actually hit their area. Okay, so what is a storm-based warning? Last summer, or last severe weather season, was our first full season using this new method of warnings. In the past, when we would issue a warning, we were issuing that warning for the entire county. So it would be in effect for maybe all of Genesee County or all of Saginaw County. And this year what's different is, or this past season what was different was that now we're actually issuing those warnings for just a fraction of the county. And what we're doing is actually really catching up to where the science is, because the science is good enough that we can tell if that warning needs to be in effect for the whole county or if it only needs to be in effect for a fraction of the county. And there's no reason to have people who aren't threatened seeking shelter, going to their basements, or doing whatever action they need to do if they're not really in the threatened area. And so now what we actually do is issue these warnings for just a fraction of the county. And those show up right on our webpage. They show up on the radar if you're looking at the radar data. And those are also going to be showing up on the television broadcast. When the meteorologists on TV are showing you the severe weather, they're going to be highlighting these areas so that you know whether or not you actually need to respond to your location. And especially for tornado warnings, that's going to provide you a lot of help. This here is in Sanilac County. You can see that a pretty small area of the county is the only portion of the county that's covered by that tornado warning. And so if you're not in that little box, then that means that you don't have to seek shelter. I do want to note on this topic that if you're hearing those tornado sirens going off for your county, then those are still, for most counties, going off for the whole county when something is issued anywhere in that county. And so some of the dissemination methods haven't quite caught up yet, but most of the visual dissemination methods, looking on the internet, looking on the television, this is going to be able to provide you with a lot more information. Okay, so we're moving on now to what kinds of dangers we're talking about for thunderstorms. And when we talk about severe weather and for thunderstorms, the thing that we most commonly think of is tornadoes. That's the big attention getter. That's the one everybody's kind of excited about. But actually here in Michigan, tornadoes make up a relatively low frequency of our severe weather hazards. Here in the state of Michigan, we average about 16 tornadoes per year. And in southeast Michigan, which is just that little portion of the state that our office covers, we average about 6.5 tornadoes every year. And so that's going to fluctuate. That number's going to fluctuate some from year to year. Some years we have more tornadoes, some we have less. Last summer we only had 1 tornado in southeast Michigan. The year before we had 10. So that number does fluctuate a lot from year to year, depending on whether or not we end up with maybe a tornado outbreak occurring. So what we're going to start off talking about here is the rest of the severe weather, the straight line winds, the large hail, the flooding, the things that actually cause most of our damage, cause most of the costs and injuries with the severe weather we experience here in Michigan. Okay, so starting off, we're going to cover lightning, winds, hail, discuss all of those different things, get everybody on the same page as to what we're talking about. And the first topic we're going to cover is straight line winds. And so what a straight line wind is, for anybody that's not familiar with that, is basically strong winds that come down out of the thunderstorm and blow in one direction. Okay, and so a lot of the time when people see wind damage, they think, especially if it's very strong wind damage, they think a tornado must have come through my community. And that's not necessarily the case. We can see wind damage that will produce the same damage as a weak tornado. Things like trees being knocked over, or damage to your roof, or maybe your trampoline's been blown into a neighbor's yard. All of those types of things can be caused just by these straight line winds. We consider these straight line winds to be severe when they get to be 58 miles per hour or more. And on rare cases, these winds can even exceed 100 miles per hour. So these can be very strong. Some of our weak tornadoes start off with about 60 mile per hour winds. So these winds really start off about the same range as a weak tornado, going up to about 100 miles per hour on the rare cases. The one thing that is noticeable about these winds, though, when you have a tornado that touches down and it has a fairly narrow path that it takes, right? And so with these straight line winds, what you actually have is sometimes very widespread damage. And that's why it does contribute to a lot more of the damage costs and does produce more widespread damage than a tornado. Last year we had a very significant strong wind event back on June 8th of 2008. And some of you may remember this. Some of you might have been out of power for some time. Some residents here in southeast Michigan were out of power for up to a week after this day. So it was a very widespread wind damage event. We're going to talk a little bit more about that coming up here in a minute. So this is just kind of a picture to give you an idea of what you would be possibly seeing if you were maybe in an area where there weren't any trees and you had some real good visibility. You can see here in this image that as the strong winds come down out of the thunderstorm, they just kind of blow out all in one direction. And you can tell that they're so strong here that they're actually picking up some of the dust and some of the dirt off of the ground, and that's what you're actually seeing here, blowing out in front of these strong winds. And this is the type of damage that we're talking about. The very strong wind damage, knocking over maybe some very large trees, causing a lot of damage to buildings and things like that. All right, a couple of different words that can also describe these straight line winds. Sometimes we refer to it as a downburst. And downburst, you can see here in this picture, all of these trees down in a fraction of the forest, all from just those straight line winds, nothing that has to do with the tornado. And then also a derecho, which is actually what we had last year on June 8th, which is a very long line of storms producing these very strong winds. All right, got a little video clip here for you to show you some of the damage that we had last year on June 8th from this type of strong straight line wind.
As fast as storm ever I've seen come in.
The trees are all gone. We lost all of them. They're probably about 200 years old.
Well, if I was laying in my bed, I wouldn't be here talking to you today.
Mark and Michelle Burness were on their way home from up north Sunday when a neighbor called with the bad news.
She was kind of frantic and just said it was not good.
One tree on their home, one tree in their home. This Waterford family, just one of the many on Pleasant Lake with serious storm damage and widespread power outages.
That was a nice, beautiful, tall pine, and now my work van looks like it won't be working for a while. Yeah, it came in fast. It's like you didn't have time.
It did happen remarkably fast, according to the National Weather Service. Believe it or not, it wasn't a tornado. Instead, meteorologists say the winds went from dead calm to 60 to 80 miles per hour in just 5 to 10 seconds.
Everything just started coming across. All the water, all the sticks, branches, all the trees started falling down.
Waterford, not the only community cleaning up. Farmington Hills had some damage as well. You can see the wind rustled this enormous evergreen right out of the ground. Fortunately, it fell between houses, not on them. At the Del Bell family home, the neighbor is supplying power, and they're grateful the damage wasn't worse.
Out of nowhere, this thing came crashing down behind us.
The crack of the tree coming down and like the thunder and then the lightning. We were scared.
Yeah, we were scared when it was raining and things that were stationary started coming down, so yeah, that was scary.
In Oakland County, Amy Lang, Fox 2 News.
All right, so definitely some very extreme damage, and our office is located near Waterford, which is one of the hardest hit communities with these storms, and so this was probably the most widespread damage that I've ever seen from just straight line thunderstorm types of winds. All right, what you're seeing right now is a radar loop from that day back on June 8th, and we call this a squall line or derecho. What this is basically just a long line of thunderstorms, and the strongest winds are going to be right on the leading edge of that thunderstorm. And so looking back on this day, I know there were a lot of people, it was a Sunday, and there were a lot of people outside recreating. It was hot out. People were out on their boats, out on the water. And a lot of people were caught quite off guard by these storms. It was a nice day before the storms hit. You can see there's very few thunderstorms developing out ahead of that main line. It was basically clear before the storms actually arrived. But the storms did move in rather quickly, moving about 45 miles an hour. And then again producing very strong winds, 60 to 70 miles per hour in most areas, and some locations up to 80 or 90 miles per hour. And some of those strongest winds occur right where you see those kind of bows in the line. And right where it bows out like that is where those winds are intensifying and rushing out ahead of the line and even causing them to strengthen even further. Okay, and one of the things that you might have seen if you were outside the day that this storm came through is something called a shelf cloud. And what a shelf cloud is basically a low, horizontal, wedge-shaped cloud that extends from the base of the thunderstorm. And so as this line of thunderstorms was approaching you, you might see a feature like this, where you have this low cloud that's kind of hanging down, pointing towards you as this line of storms approaches. And so that's one of the things that you might see, a feature that you might be able to notice. And as you see one of these shelf clouds, you know that pretty soon the winds are going to pick up quite dramatically. So on this day, they picked up very strongly. You might only have winds pick up to 40 or 50 miles an hour. But these shelf clouds are a very noticeable type of a feature. And so if you see something like that, that's something you can say, okay, I need to start acting, we need to get inside. I recognize that. That's something that could lead to some very strong winds. And really, it's going to stand out to you anyways. It's a feature that you'll say, well, that doesn't look normal, that doesn't look right. And then you know, okay, let's go ahead and get inside and get somewhere safe. So with these, I want to point out that this is on the leading edge of the storm. So it's not raining yet before it gets to you. All the rain is going to be behind that shelf cloud. So you don't really have any advance notice that those strong winds are about to hit you, but as soon as it moves overhead, those winds are going to pick up very quickly. All right. This is a video. Let me get it playing here. And you can see the shelf cloud develop right as this line of storms approaches you here. So here's our shelf cloud. And this is time lapse, so it's going a little faster than normal. And then you'll notice the winds really start to pick up here. This cloud of dust rolls through with that shelf cloud. Okay, the next hazard we're going to talk about is hail. And we consider hail to be severe when it's 3/4 of an inch or larger. And that's what we've done in the past. However, something's going to be changing with hail sizes. And soon we're going to be considering hail to be severe starting April 1st when it gets to 1 inch. And so this is kind of an experiment we've been working on for the last couple of years determining, and I think we're at this point going to go ahead and start using 1 inch as the new hail criteria for a severe thunderstorm. And so most of the hail that we have here in Michigan is on the relatively small size, usually somewhere between that little pea-size hail that looks like a little green pea, maybe up to something the size of a golf ball. That's usually about the largest we see. Occasionally you might get something as large as a baseball, but that is pretty rare here in Michigan. You can get some pretty bad damage from these hailstorms, though. On July 26th of 2007, over in Durand, just over in Shiawassee County, they had hail fall for 50 minutes, so almost a whole hour of hail. And the largest hailstones that day were up to golf ball size. And so that caused just widespread damage across the city of Durand. They had cars with broken windshields, damage to homes, the siding was messed up on some of the houses, crops were destroyed, trees were damaged, and so very extensive damage from that hailstorm. And I think that's kind of rare. Usually we think that hail is only going to last for a couple minutes or two, so very strange to see it persist for a whole hour almost like that. Okay, and then just again, remember that starting April 1st, if we do issue a severe thunderstorm warning, that means the hail we're expecting to be up to 1 inch, or you're going to get those strong winds over 58 miles an hour. Okay, and so when you're talking about hail sizes, we commonly refer, when we're talking about the size of the hail, to a similar object that would be the same size as that hailstone. And part of the reason for that is because when the hail is falling, we don't expect you guys to run outside and try to figure, is it 3/4 of an inch? Is it an inch? Is it an inch and a half? So that way you can look at the hail from inside your house or wherever you are where you're safe, say, oh, that looks like the size of green peas, or it looks like M&Ms. It looks like $50. And so we try to use objects that are standard size, like a coin or a ball, to compare to those hail sizes so that when you make that report to us, we know exactly what you're talking about. Now, some parts of the country, not too often here, but you can have much larger hail sizes. You can have hail up to the size of grapefruit. You can even have hail the size of DVDs. So hail can get very large. So just try to avoid going out in hailstorms. You're never quite sure how large that hail is going to get. But it can get very big and even break your windshield. So don't want to be driving around when the hail is falling. Okay, so just to recap, we do issue those severe thunderstorm warnings, meaning that one of two things is expected. We either expect those strong winds, 58 miles per hour or more, or hail to 1 inch starting April 1st. So we don't issue severe thunderstorm warnings for lightning, we don't issue them for flooding or for tornadoes. It's just for one of those two things to occur. All right, so going back to tornadoes then, we do average 16 tornadoes a year in the state of Michigan. Here in the United States actually gets more tornadoes than any other country around the world. And that has to do with the geography of the United States, having the Rocky Mountains out west, and then we have the air coming over the Rocky Mountains, meeting up with all that deep moisture coming up from the Gulf of Mexico. And the combination of those two air masses is what spawns so many tornadoes down in Tornado Alley in the Plains states. But we do get our fair share of tornadoes here in Michigan. Hopefully we don't see too many this year, but we do get some tornadoes here in Michigan. Fortunately for us, most of our tornadoes are on the weaker end of the spectrum. We classify tornadoes on a scale going from EF0 being the weakest up to a 5 being the strongest. And EF stands for the Enhanced Fujita Scale that we use to classify the tornadoes. And so fortunately, most of our tornadoes are quite weak, on the weaker end of the spectrum, almost 70% of those tornadoes. And most of those are on the ground for less than 10 minutes, the track is less than 3 miles, and wind speeds are less than 110 miles an hour. And so, unfortunately, with these very weak tornadoes, they don't last very long. And so if there is a tornado that we're going to have a hard time getting a warning out on, it would be this type of a tornado. If it's only on the ground for a couple of minutes or less, that's a hard tornado to catch. You start getting into your stronger tornadoes, and those are going to show up very well on the radar, and we're going to have a much easier time catching those. But this is something that is especially that we rely on our spotters to help us with. If you do see one of these smaller, weak tornadoes, that's something that you can tell us about that might help us issue a warning that could help the rest of your neighbors and your community. All right, we've got a little clip here. This is actually the next category of tornadoes, getting into the EF2 category. But this was a great video that was caught on a surveillance camera down in Alabama last year. So I'm going to go ahead and play this for you and let you see what it looks like as this fairly small tornado comes through. Kind of a good representation of the type of tornado we would get here in Michigan, because you can see even within this parking lot that some of the cars are damaged severely. They're picked up and thrown, while some of the other cars there aren't damaged at all. And so fortunately, having a lot of the smaller sized tornadoes, you may not see that half-wide tornado that they have in the plains, which is a great thing. You might get something smaller that would cause damage more similar to this. Okay, so the other 33% of our tornadoes range in strength from the EF2 to the EF5 category. Those types of tornadoes can be on the ground for anywhere from 20 minutes up to an hour, and typical duration can be anywhere from 15 miles up to 50 miles, so they can track quite a long distance across the entire county even. Wind speeds ranging from 111 miles up over 200 miles. That's about the top of the spectrum, though, around 200 miles, we think. And these do develop from very well-organized thunderstorms, and we're going to go through the tornado formation process here in the second half. But these are much easier for us to detect on the radar. So when we see one of these tornadoes develop, it's from something that has been persistent on the radar. It's been a strong thunderstorm tracking across the area for a long period of time, something we can follow and watch as that rotation starts to come down to the surface. All right, and this is some of the damage that you might see from one of these stronger tornadoes. If you guys remember the tornado that hit Fenton 2 years ago, the picture on the left here is from right as that tornado was developing back in Livingston County. And so that's EF2 damage there. You see a lot of damage to the second story of the building. And then this is EF3 damage from a tornado that occurred down in Ohio back in 2002. And so damage is getting very extreme at this point, where the building is probably, suffered some pretty bad damage that may not even be able to be repaired at that point. All right, luckily for us, we only had one tornado last year here in southeast Michigan, and it went through Plymouth, down there on the southwest side of Detroit. This is a track of the tornado. You can see that it actually developed and tracked right over the interstate. So that must have been the site if you were driving along there at that moment. This occurred on September 13th, and most of the track of this tornado was on the very weak side. All these little yellow pins on here indicate where EF0 damage was observed. And EF0 damage is typical of trees down or power lines down, street signs knocked over, things like that. However, there was this small area right here where the tornado intensified up to an EF2 damage. And that occurred, kind of hard to see here, but where all these trees are is a river valley. And so we actually think that as that tornado had developed, it tracked over the river valley, which was a little bit lower, and so the tornado kind of stretched and caused it to intensify right there in that location. So, unfortunately, in that one location, though, there was a couple of apartment complexes, and this is some of the damage observed with that tornado. Okay, so moving on, are tornadoes and funnel clouds the same thing? We get a lot of reports where these words are kind of used interchangeably, and they're not the same thing. What a tornado is a violently rotating column of air that is in contact with the ground. Okay, and then to contrast with that, a funnel cloud is a violently rotating column of air that is not in contact with the ground. So they both have that funnel-like shape, but you can see the difference between the funnel cloud that's not touching the ground and the funnel cloud that is. And we're going to go much more into detail coming up about the differences between the two. One of the things, though, is you can see that there is no debris at the surface. The funnel doesn't extend all the way to the ground, and more importantly, is that there's no damage occurring. There's nothing swirling around down at the bottom that you can see. And so that's really what helps you figure out if it's actually a tornado or not. Okay, so a couple of true or false here. Let me know what you guys think you're seeing. What's that one? Is that a tornado?
Tornado.
All right, that's a pretty easy one. So true, that is a tornado. Funnel cloud? That's correct. It's not a tornado. We don't see any debris at the surface yet. How about that one? True. This is a tornado. Now, it doesn't look like the funnel extends all the way to the surface, but we can already tell that the strong winds have come down to the surface because we can see all that dirt and debris starting to blow around at the ground, and it is causing damage to whatever is beneath it at this point. All right, that one is a tornado too, and you can almost not see the funnel at all here, but you can still see that there is that debris at the surface. And so that's something that's really important to look for, especially as that tornado is just developing, looking for that debris cloud spinning around at the surface. And you know, when you think about a tornado, what a tornado is, it's a violently rotating column of air. And air is basically clear, right? If you don't have anything in that air, how do you see it? Well, all you're seeing with the tornadoes, when you're seeing the funnel, you're seeing that moisture coming down from the cloud, or you're seeing that debris being picked up from the surface. So if the tornado is just developing and that spiraling air hasn't filled in yet, then you might not actually be able to see anything going on that would let you know that funnel's coming all the way down to the ground yet. Okay, a feature that you might see before you actually get that funnel cloud or that tornado to develop is something called a wall cloud. And what a wall cloud is a localized and persistent lowering from the cloud base. And so it's going to be something that's also going to be rotating. Now, it's not going to be rotating like that funnel cloud is. It's not going to be rotating violently, but it is going to be spinning and rotating on the bottom side of that cloud. So you look up, you're seeing this rotation going on and something that's lowering down. It's not really organized into a funnel maybe, but it is kind of some cloud feature that's descending from the cloud a little bit, and it is rotating, and that could be a wall cloud. So some features that you can see with these wall clouds are that they actually slope downwards and towards the precipitation. Now, if you remember the shelf cloud that we talked about a few minutes ago, it was sloping downwards and away from the precipitation so that you were hit with the rain right after it goes by you. This is actually sloping downwards and maybe towards the precipitation. So that's one thing that can help you keep the two features separate. Another thing is that these wall clouds are kind of a localized, kind of a smaller cloud feature compared to that shelf cloud that was something that would extend all the way across the sky. And so that's how you can kind of keep those two separate in your mind. Okay, so there's the two in comparison. We have our shelf cloud pointing down and away from the rainfall. And then we have our wall cloud that's kind of sloping downwards and towards the rainfall. And this isn't the best picture of a shelf cloud. It's you would actually think that it would extend all the way across the sky and you would really be able to see it quite well. So that's how you kind of keep these two features separate in your mind. Okay, and so one of the things that we tried to do this year with this presentation is to incorporate a lot of things that you might think you're seeing, but you might not actually be seeing what you think you're seeing. So the sky is very tricky. So we've included some lookalikes here to fool you guys a little bit. So as you're looking for a tornado, I just want you to keep in mind that the things you're looking for are going to be that debris cloud near the ground and that violent rotation along that vertical axis. So those are the two things that you need to really look for when you're trying to identify a tornado. Helps if you can see that smooth funnel, but you might not always be able to see that. Okay, so here are some pictures that look like they might be tornadoes. And this is hard because I know these aren't videos, so you can't really see if it's spinning. But actually, none of these pictures are tornadoes. And this one especially is deceiving, I think. But what these are just low cloud fragments that are kind of hanging underneath the cloud deck. And this is very confusing. People see these things, and I'm sure if I saw this, I'd be thinking, oh my gosh, there's a tornado over there, I'm pretty excited. But what you have to do is just monitor the tornado. If you feel safe, if you don't feel safe, get to a safe shelter. That's always your first priority. But if you're in a safe distance away and you notice this, the first thing you want to look for is it rotating and is there debris and damage going on at the surface? And so what these clouds are, we call them SCUD, which stands for stratocumulus under deck. So it's just a low type of hanging cloud that kind of is just hanging out underneath the main cloud deck, but looks very, very misleading. All right, the next pictures here, these are also not tornadoes. What these are rain shafts or virga. So this is basically just rainfall off in the distance. What virga is just rainfall that's off in the distance that evaporates before it ever hits the ground. And so again, some of these can be pretty deceiving. These are some pretty far off views, and this is something that you'll especially see if you travel out to the western United States where it is so dry. It almost looks like there's some rain with a tornado embedded in there. But again, all of these are just different ways that the light is hitting the rainfall or the rain that's evaporating from the cloud and kind of playing tricks on your eyes. All right, and then this next set here are all pictures of smoke. And smoke can be especially tricky because as smoke rises into the sky, sometimes it catches a little wind and it does kind of form a little eddy or something. But again, the features to look out for, smoke is something that might be kind of moving around a little bit, not real organized. It won't have that classic funnel shape to it filled in, not going to be violently rotating, and there's not going to be any debris really at the surface. So we just included these to show you that it really is a challenge to sometimes to figure out what it is you're actually seeing out there. Okay, we also have some flooding threats here in Michigan, and there are 3 different types of flooding products that we would issue to keep you guys informed about how bad the flooding will be. The first one up at the top there is flash flooding, and this is the type of flood warning that you'll probably hear about the most in the summer. Meaning that we have had a heavy amount of rain in a short period of time. And so usually when we have flash flooding, we're experiencing something like 3 to 4 inches of rain in an hour or two that is really causing some significant drainage problems across the area. So things where cars could start getting stranded or different things like that. And flooding is always unique because if you live in an area that really does have good drainage, you may never be a victim of a flood. But there are other parts of the area, and especially in an urban area like this, where that water can't soak into the ground fast enough sometimes, or the pumps fail, and things like that happen. So flash flooding, again, pretty heavy amount of rain that could cause some very significant problems, whether water coming up in your yard, into your house, things like that, or blocking roads and causing roads to be closed. The next type of flooding, river flooding, we have several rivers across the area that have gauges on them. And so we monitor those gauges for rises on those rivers, and that could be due to snow melt or heavy rainfall or ice jams. And when we see those river gauges start to go up, then we start issuing river flood warnings. And so that would be something you'd be concerned about, especially if you live near a river or a river floodplain. And then lastly is aerial flooding. And aerial flooding, or an aerial flood warning, is kind of more of the long-term type of flood warning. Maybe we've had heavy rain for 2 or 3 days straight, and you're really starting to see some significant flooding problems from that. We've issued a couple of these this winter when we had 15 inches of snow on the ground, and all the snow was melting, and we had rain falling, and the ground's frozen, so the water couldn't sink in. So that kind of lasts over a longer period of time, 6 hours to a couple of days, and we might issue one of these aerial flood warning type of products. This is a map from last year, September 12th through 14th, when we did have some very heavy flood across the area. And looking at this picture, anywhere where you see the red is where we're getting up to between 5 and 6 inches of rain in under 48 hours. So very significant rainfall, and this actually came up through Michigan due to two different tropical systems that made it up through the state. The first one was the remnants of Tropical Storm Lowell from the Pacific Ocean that got caught up in the prevailing wind pattern and made it all the way up here into Michigan. And then the next day we got hit by the remnants of Hurricane Ike, which, if you remember, hit Texas pretty hard. And so the combination of those two systems getting pulled up into here, we ended up with 5 or 6 inches of rain, and especially some bad flooding out towards Hamburg along the Huron River over there. Okay, this is not a local video, but this is a pretty shocking video of somebody that makes the mistake of driving into floodwaters. And, just to remind everyone, you are never supposed to drive into floodwaters. The water can be extremely powerful, and it can be misleading. Sometimes you think, oh, it might not be deeper, but maybe the road dips and you're not aware of it, and then all of a sudden you're in 1.5 feet of water. So we're going to play this video and show you the bad situation this woman got into. So cars aren't meant to float. 6 to 12 inches of water is all it takes to make your car float, and 1 to 2 feet of water to float even a larger truck or SUV size type of vehicle. So never a good idea to drive into floodwater.
Who's taking this right there?
I think there is a helicopter over top of her at this point, filming it. That's right. Turn around, don't drown. That's our slogan that we have.
It's really scary when it happens to you, because I was in the car, the front wheel, the driver said, no, that may not be that deep. Picked up the front wheels, burned the ditch, and water's flooding through the hood inside the car.
Oh my gosh.
I mean,
Yeah.
you respect it. You see flowing water, you have to obey.
Yeah, definitely.
Does the Weather Bureau have the capacity to monitor the ice that came off of Bay City and caused the big problem a couple of weeks ago?
Yeah, we really didn't know too much about that going on until it was actually happening. We're looking into that and trying to figure out what we can do next time to find out about that. There was a case a week or two ago when strong northeast winds caused all of the ice that was on the Saginaw Bay, or not all of it, but the ice on the Saginaw Bay to start moving into the houses that were adjacent on the shoreline. And that was just terrible, but that is something that we're going to start kind of looking into a little bit more. So, you couldn't tell here, he did lift a small child out of the car, 1 or 2-year-old, that was in the car with her. She was probably very lucky that she got caught on the bridge and was able to have somebody help her and her child get out of the car. So these people actually ended up being on the Ellen show after this happened, and Ellen was nice enough to give the man that rescued them a week-long vacation to kind of thank him for being a good Samaritan. She also gave the woman that drove into the floodwater a new vehicle. So, I don't know if that is the right idea. Very nice gesture, definitely. I'm sure the woman appreciated it and was very, shocked by what happened to her. But we thought maybe it should have been the other way around, that the Samaritan got the new car and she got a trip or something.
Sure, he got a trip.
All right, so I want to go over a couple of definitions that are real important to know the difference between the two when we start issuing all of these severe thunderstorm, tornado warnings, and watches. The first one is a watch, and what a watch means is basically to watch out later on today because we're expecting some bad weather. The watch is something that's usually going to come out maybe 2 hours to 6 hours before the thunderstorms ever arrive at your location. And so when we issue that watch, all that means is you don't need to go, if it's a tornado watch, you don't need to go to your basement right away or anything like that. All you're going to need to do is stay tuned to your television or however it is that you're receiving weather information in case something does happen later. So it's not a good day to go out hiking or go out into the woods where you're not going to be able to get to shelter. Or it's not probably a good day to go out on your boat or anything like that. But that's something we issue to give you a heads up a few hours before the storms ever develop. By the time we start issuing the warnings, that is actually the time that you need to respond and take action immediately. If it's a severe thunderstorm warning, you need to get into a building, a sturdy building. If it's a tornado warning, you need to get into a basement. And so those are the differences between the two products, and real easy to get them confused because they both start with W, but watch means just watch out, and the warning is the big one when you actually need to take action right away. Okay, so to give you a look at how all these products kind of scale down in time as we get closer to something happening, we start off a couple of days before the weather ever occurs with something called an outlook. And the Storm Prediction Center is kind of issuing these types of outlooks for the whole country. And so they'll maybe highlight a whole region that says, this whole area could see the threat of severe weather in the next day or two. Then as we get closer in time, as we get into that 2 to 6 hour time frame, we'll start issuing watches. And the watch is still going to be for a fairly large area, maybe all of lower Michigan or all of southeast Michigan and northern Indiana. And so the watch is still a pretty large area. And then the warnings are what we start issuing when the storms are actually showing up on the radar. They're expected to impact the area that the warning is issued for sometime in the next 10 minutes to an hour. And really time to take action immediately. Okay, so as far as you guys are, you're our weather spotters. When is it time for you guys to take action? And maybe this applies more to some of the amateur radio folks or the people that are really interested in weather and want to go out and really follow the storms. So if you're trying to figure out when do you activate your network, well, sometimes if you're trying to activate your network when we issue a watch, you're going to be in a position where you activate your network and nothing happens for 4 or 5 hours, and so you're really sitting around kind of waiting for something to happen. Likewise, if you wait for us to start issuing warnings, it's kind of too late because by then stuff's already going on, and if you're trying to get people up to speed, then you might not have enough time to do so. So it really helps for anybody that has an interest in the weather and wants to be more actively involved in the weather spotting process to kind of keep an eye on the radar to see what's going on for yourself. So if you see the storms are developing in Shiawassee County, or we're issuing warnings already for Livingston and Shiawassee County, and you're in Genesee County, that means it's getting closer to you and time to maybe start preparing for whatever might be coming your way. Okay, so again, just some activation basic ideas, monitoring the radar trends and upstream conditions, using the resources like outlooks and radars and internet will let you know even a day or two ahead of time if you're trying to plan to be prepared for that. And anytime that you think that there's a threat, you can be proactive and kind of prepare yourself for whatever is coming your way before the storms actually hit. You can tell when it's getting dark out there. You can tell when it's looking threatening. You kind of have an idea when the storms are about to hit your area. Okay, a couple of great sources to get weather information. There's so much information available to you on the internet, and our website is on that handout that all of you got outside. And so you can go to our website and see all that information, look at the radar data, look at the satellite imagery. And so that's a lot of information available there. There's also great information on the television and radio. So, make sure that you're monitoring the television stations. A lot of the channels will sometimes go to full-time coverage when there's a big severe weather event going on. And then the weather radio is another great resource, and we're going to talk about that here a little bit more. First off, though, starting off on our website, this is what our website looks like. You can get a forecast by clicking on this map at any time, and then we also have any hazards that are in effect showing up color-coded on that website. So you can click on any of those different shaded areas, and that's going to tell you what warning is in effect for that area. You can click on any point, and that's going to get you a local forecast. We issue these forecasts based on little 5-mile by 5-mile grid boxes, so it does vary from location to location a little bit. You can have access to the radar and satellite imagery down here at the bottom. And then there's just a whole other wealth of information over here. If you're looking for observations, you want to know what temperatures are, what the winds are doing. If you want to come up here to the top, there's a little tab that'll show you a whole list of all of the warnings that are in effect across the whole area. So really great information available on the website. Okay, can I see a show of hands of how many of you know what a weather radio is or have a weather radio? Wow, okay, so that's a great number, and I'm really pleased to see that. For those of you that aren't familiar with the weather radio, what the weather radio is a small radio that looks like one of these that you can program for the county that you live in and for which hazards you want to be alerted to. And so when there's no bad weather going on, you can turn this weather radio on at any time and it'll broadcast a forecast for you. But when bad weather actually starts, this weather radio will act kind of like a smoke detector for you, almost. Where the radio will sound an alarm when we issue a warning for your county, so that you don't have to be paying any attention at all, but as long as you're close enough to hear that alarm, which is pretty loud, and it's close enough to wake you up if you're asleep. So if we do issue a tornado warning at 2 o'clock in the morning, you might not hear the outdoor sirens going off if your windows are closed or something like that. But if you have one of these weather radios in your house, then that's going to be loud enough to wake you up and let you know you need to get to shelter. Because with a tornado warning, you don't have a lot of time to respond. Sometimes those warnings only come out just a minute or two, or a couple minutes before the tornado might hit your area. So definitely need to respond quickly when something like that happens. I have one of these weather radios in my bedroom. I think they're a really great resource for anybody to have. And we've got a little clip to show you what it sounds like.
The National Weather Service in Detroit, Pontiac has issued a tornado warning for St. Clair County in southeast Michigan, Macomb County in southeast Michigan, until 2:30 p.m. Eastern Daylight Time.
All right, so it's all a computer automated type of a voice, but that's really to help that information get out there faster. We used to, after a warning was issued, grab the warning, run over, and record it, but that's been years since we kind of switched over to the computer voice, and that way we can get that information out to all of the counties very quickly when we start issuing those warnings. All right, moving on to weather safety, so we all know how we actually need to respond when these strong storms hit. I want to remind everybody that even if you're a big weather buff and you even like to go storm chasing and that kind of stuff, you need to keep your safety as your number one priority. So, going out in the middle of the hailstorm to get a good spotter report for us, we appreciate the information, but just make sure that, you're taking care of yourself first and foremost. Okay, so as far as thunderstorms go, it is never safe to be outdoors when thunderstorms are coming. All thunderstorms, by definition, have lightning and therefore are dangerous. And so we don't issue any particular types of warnings just for thunderstorms because we would really be putting those out a lot and you guys would get really tired of them. But if you're close enough to hear that thunder and see the lightning, you're close enough to be struck by lightning. So that's just something to keep in consideration as you're making plans over the summer months. Some things you can do ahead of time is just pay attention to what's going on with the weather forecast so you know if you're going to need to maybe get to a shelter quickly. Postpone outdoor activities. You can't swim during the thunderstorms. Water's a great conductor of electricity, which is also why you should avoid showering when thunderstorms are going on. And we also have on here not to use a telephone with a cord. Most people are now using cordless phones or cell phones, and those are safe in thunderstorms because you're not actually connected to anything. But the phones with the cords, you're connected into the electricity to some extent, and you don't want to be using those. All right, and so it is safe to seek shelter in a car or building during just your basic average thunderstorm. Now, once that thunderstorm starts to intensify, you're not really going to want to be in your car anymore, so that's kind of the judgment call you have to make there. Okay, as far as lightning goes, we consider a building to be safe from lightning if it's fully enclosed with a roof, a floor, and it has indoor electrical plumbing and wiring. And so some shelters that are not going to be safe in your thunderstorms include picnic shelters, pavilions, large tents, sheds, and any building that's not fully enclosed as a permanent shelter or a permanent building. What you're needing is you actually need that electrical and plumbing in the walls to ground the current down to the ground. So without that type of grounding mechanism, then these other buildings, like a basic shed, is not going to protect you from the lightning. Okay, when we've issued either a severe thunderstorm watch or a tornado watch, again, you still have plenty of time at this point, most likely until the storms arrive. At this point, all you need to do is stay tuned to weather information and alter your plans if necessary. Then as we start issuing those severe thunderstorm warnings, you need to make sure you get into a sturdy building. Again, the car is no longer a good shelter for you. You want to stay away from windows, and then you also need to monitor for upgrades to a tornado warning. A lot of the time we might issue a severe thunderstorm warning, follow that up maybe 10 or 15 minutes into it with a tornado warning if it looks needed. And so just because you have a severe thunderstorm warning doesn't mean it's not going to be converted over to a tornado warning. All right, then when we actually go ahead and issue that tornado warning, you know the basement is the best place to be if there's a tornado warning in effect. If you're down in the basement, you want to get underneath something sturdy. So get underneath a desk or a table or something so that you have a little extra protection over top of you in case debris starts to fall in on you. You want to also get in the tornado safety position, which is covering the softer side of your body, getting down on your knees, covering your head and your neck with your hands. It's a good idea also to cover yourself with pillows and blankets, because if you do have that debris falling in, then having, an extra layer of covering so that dirt doesn't get in your face and things like that, definitely a good idea. And then make sure you stay in the basement until the warning expires. Okay, there are also going to be times when you are somewhere and a tornado warning is issued and you do not have access to a basement. That's just how it's going to be. And for the most part here in Michigan, if you remember back to the beginning, most of our tornadoes fit into that weaker category where they're not going to, demolish a building. So there's a lot of good shelters that you can get to in most buildings where you're going to be relatively safe from those tornadoes. But what you need to do, if you're in a building, you want to make sure that you get to the lowest level of the building again, and then get to the interior part of the building. So you want to be away from all the outside doors and windows, and things like this are going to be flying around. Things like 2x4 pieces of wood are going to be flying around in that tornado. And so if you're near the exterior walls of a building, this piece of wood is probably extending clear on into the inside of the building. So you don't want to be hit with any of that debris. So by putting yourself into the middle of the building, sometimes a bathroom or a closet are good, safe places to be. You can think of it this way, that you want to put as many walls between the outside of the building and the room you're going to be in as possible. So that way, the tornado would have to go through many walls before it got into where you actually are. And most likely would be gone by then. So just something to keep in mind. We also have on here, it's never safe to be driving when there's a tornado going on. If you are driving, you run the risk of, especially here in the city, getting caught in a traffic jam or at a red light or in a row of traffic. It's much better if a tornado warning is issued. Pull over, get into a building, a safe building, maybe it's a McDonald's or something. It's going to be better than being in that car if a tornado hits you. All right, and you don't want to try to outrun the tornado. Again, a lot of things can get in your way. And tornadoes can change directions. They're not real easy to figure out as far as getting away from them. Okay, so let's see. We've got a few tornado myths up here that some of you have probably heard at least one of them or more. It used to be a myth, especially when I was in elementary school, that you wanted to open all the windows before the tornado came. And the idea was that the pressure was going to drop so rapidly with the tornado that it would break all the windows. Well, in reality, the tornado is probably going to break all of the windows anyways due to the force of the wind. And so you don't need to open the windows. They're going to get probably damaged regardless whether they're open or closed. And if they don't break, then that offers an extra layer of protection from that debris that's spinning around. Plus, the last thing we need people doing when the tornado is approaching is getting closer to the windows and closer to the outside of the building. So leave your windows closed, that's fine. Recently, we've seen some people that have tried to seek shelter underneath those highway overpasses. We've seen a couple of television crews especially trying to do this. And that's not a good source of protection. As the tornado is approaching one of those overpasses, it has to the winds have to actually locally increase as they go through there, because it acts like a wind tunnel. And so those winds are coming along, and then they kind of squeeze together to go through underneath one of those overpasses. So that's not a good protection. We have heard stories of people that have been sucked clear out of those. So again, you need to get into a building if there's a tornado coming. A couple of other myths. Tornadoes never strike big cities. Well, we have seen tornadoes hit Atlanta. There have been a tornado in Salt Lake City, which is, pretty rare. Oklahoma City was hit by a very strong EF5 tornado back in 1999. So we do have tornadoes hit big cities. One hit Plymouth, which is just on the southwest side of Detroit last year. So that's purely just a myth. Your town is protected for some mysterious reason just because it's never been hit. Nobody can remember a tornado coming through, so we must be safe. That's not true at all. The city I grew up in, everybody told me, well, we're kind of down in the valley, so if a tornado comes along, it's going to go over top of us and not really touch down, so we're fine. And that's just a myth too. So there's lots of myths floating around out there. But tornadoes can occur in valleys, they can occur in mountainous areas, they can occur anywhere. So no location is really safe from tornadoes. All right, before the severe weather ever strikes, we want to advertise this website going to www.ready.gov. And we think that this is a great website, really for all types of hazards and all types of disasters. Ready.gov highlights 3 steps to planning for different incidents, including making a kit. And they really recommend having a kit that has enough supplies in it for 3 days for you and your family and everybody that you live with. So that kit needs to include food and water for 3 days, along with any medications you might need, diapers if you have small children, anything that you might need to live for 3 days in case you can't get additional supplies or in case you're stuck somewhere. That could also include things like flashlights or money. You guys remember the blackout a few years ago. So there's a lot of different situations that you kind of need to plan for. The next step that they advertise is to actually go about and make a plan. And not just for sort of severe weather or tornadoes. Plan for fires, plan for another blackout, plan for a terrorist attack. And so it gives you a whole slew of different hazards to kind of keep in mind and plan for so that you're prepared if something happens. And then the last step is just to stay informed. And most likely you guys are a group of people that do stay informed because you're here participating in a program like this, which kind of means that you're somebody that's a little more active and a little more aware of what's going on. So just staying informed with what's going on with the news and if there is a severe weather threat and things like that. Okay, so I'm going to talk quickly about what it is that we actually want you guys to report to us. What to report, what not to report, how to report it, and whether you should give us a call or not. Okay, so starting off with wind, we want you guys to report to us anytime you're observing wind gusts of 40 miles per hour or more. And you're probably thinking, well, I don't know how strong the wind is, but the handout that we gave you does have a little bit of a scale on there. And so you can reference the scale, which is the same one that's up on the screen. And so if you see things like damage to chimneys, TV antennas, shallow-rooted trees, large tree branches, you're starting to get up into that severe wind range of winds that are up around 60 miles per hour or more. And so there's a couple different ways you can make a wind report to us. If you actually have an anemometer and can measure the wind speed, you can call in that report to us and tell us, I measured the wind at 45 miles an hour. Or you can call in and tell us, I observed a tree come down in my neighbor's yard, so I'm estimating the wind speed to be 60 miles an hour. Or you can just tell us, the tree just came down in my neighbor's yard, and you don't have to even mess with the wind speed. We kind of know what sort of wind speeds will cause different degrees of damage. But we do ask that you start reporting to us at 40 miles per hour, and that helps us know if the storm strengthens and we're starting to get a stronger storm, then those winds could get closer to 58 to 60 miles per hour when we start issuing the warnings. All right, it does seem that most people, when they do try to estimate the wind speed, tend to overestimate the wind speed a little bit. And so we do ask that just when you do make your reports, tell us if you're measuring or estimating, and we will kind of take that into consideration with whatever it is that you're reporting to us. All All right, the next thing is the hail size. We want you to report to us hail when it starts to get to be a ½ inch or larger, which is the size of a plain M&M. So you start seeing M&Ms falling from the sky and start calling the Weather Service. We also have on here, up until, again, April 1st, we would issue warnings for penny or nickel size hail, but after April 1st, we are changing to just quarter size hail or larger. So again, just compare the hail size to a common sized object and make a report to us with that size. After it's stopped hailing, if you want to run out and actually measure one, that's great, but just calling it in that way is perfectly good for our needs. Again, with the hail, tell us if it's measured or estimated. And avoid using different sizes of things that might actually change from time to time. People used to call in rock size hail or marble size hail. Well, that's really quite ambiguous for us because we don't know what size rock you're thinking of. So try to just use standardized sizes when you call in your hail reports. Okay, the next report that we want is a funnel cloud report. Again, funnel cloud's a violently rotating column of air that is not in contact with the ground yet. And then, of course, we want you to report to us all of any tornado that you might see. Of course, we want to have your tornado reports. But again, just keep in mind that it is kind of tricky when you're out there spotting. So just try to be sure that it is a tornado before you make that report, because if we issue a tornado warning based on that, it can really affect a lot of people and their plans. So just try to be sure, and if you're not sure, that's okay too. Just, if you call in and you're not positive, please tell us. I'm not positive, but I think it's a tornado, and we'll probably ask you some questions to try to help you figure that out. Keep in mind with the tornado, you want to look for that rotation. If it is touching the ground and you're in a city, you're probably going to start seeing some flashes as it's taking down power lines or going through electrical areas. That's going to be one clue for you. Probably going to hear a loud roar associated with that tornado as it is causing damage to buildings. All right. We have up there good reports equal good warnings. Bad reports lead to false alarms, which kind of causes a lot of problems for everybody involved in this. People call the media, well, why did you guys talk about this tornado warning when nothing happened? And then people call us. And so just try to be sure about what you're seeing out there. So, of course, we show you something that's totally misleading next. What do you think there? Is that a tornado or not? It's hard to tell. It is playing. So if you can't tell, you would probably say, well, I'm pretty far away from this. I'm just going to keep a little bit of an eye on it. The things you're going to be looking for, is it rotating? Doesn't really seem to be. And when they're zoomed in, you can actually see it doesn't quite hit the ground either. And you don't really see any debris moving around with that. So this picture was taken down in Tennessee a couple years ago, and the first time I saw it, I was sure it was a tornado, of course. But this is not a tornado. On this particular day, there were so many people that reported the tornado to the Weather Service office down there that they issued a warning, even though the radar didn't support that there should be a warning there. And afterward, they went out and looked, and there's no damage or anything in that location. So again, this is just that scud cloud, that stratocumulus under the deck. We think that maybe there was some wind that pulled this cloud down a little bit, but just very obscure kind of thing out there. Okay, and then we also really need to know any post-storm damage reports that you have. These can be things that you report to us either right as it happens, or maybe you've been out of town and you come back later on that night and there's a huge tree down in your yard. We would still very much like to know about those damage reports even after the storms have come through. Just try to make sure that when you do make those later reports to us that you tell us what time it might have occurred, or if you're not sure, just tell us it didn't occur right now, because that can be a little misleading if we get a report an hour later that says, I just had a tree down, and we're thinking that storm shouldn't have done that. Just tell us it was from a while ago if you're not sure on the time. All right, and then we also want any reports of water spouts that you might see. We know that water spouts are much more common in this area around the Great Lakes than we find out about. So people commonly tell us that go out boating a lot, oh, I've seen 7 or 8 of those, but they've never reported one to anybody. So if you see one, please make sure you call that in too. Okay, and I know nobody wants to think about snow or ice anymore, but if you, we do take winter time spotter, winter weather spotter reports as well. We do offer a full winter spotter training class if you want to learn a little bit more about winter weather. But just in the meantime, we do want to know things like when you've received your first inch of snowfall, so we can start getting a gauge across the area how much people have, every additional 2 inches of snowfall, and then a storm total after all the snow is finished. You can see here a picture of a snowboard, and that's really a good place to measure. If you're measuring the snow and it's the early part of the season and your grass is still there, that snow might form might be 2 inches off the actual depth of the ground. And so you stick a ruler into it and that goes all the way down to the surface, but you're really measuring 1.5 inches of air before that snow started piling up on the grass. So that's part of the reason. If you're measuring on a black driveway, a colored surface can make the snow melt faster. So we do recommend kind of a white colored board if you want to send in some snow reports. Things like an elevated deck or a patio are another good thing, or any type of an elevated surface usually gives you a pretty good measurement. As far as icing goes, if you're noticing some pretty significant freezing rain or sleet, call that in. Also, if it's actually starting to accumulate, where you can see a 1/2 inch of ice on a surface, then that's another thing that we want to know. So if you can actually start measuring that ice, then please call that in. As far as flooding goes, if you've received 1 inch of rain or more in a particular storm, you can call that in. That could be a 12 or 24-hour total in the winter, or maybe it only takes you an hour to get 1 inch of rain in the summer. So if you actually have a rain gauge, you can call in those rainfall amounts, or just call in any time that there is significant flooding that is covering a road or threatening property. Now, near our office, we have a road that floods every single time it rains. And that's not really the flooding that we need to know about, because that is just a problem with the drainage in the area. But if you see some flooding that is pretty rare, that you know does not normally occur in an area, then that's a really valuable flooding report to us. And then also anytime you see river flooding or ice jams, especially if you live near a river and you're accustomed to what it normally looks like. As far as fog goes, if you're seeing any fog that reduces visibility to 1/4 mile or less, and really that's the point where it's starting to get quite soupy. So if you're noticing some dense, soupy fog, you can call that in to us. Okay, a few things that we don't need you to report. Things like 30-mile-per-hour winds and pea-sized hail, not quite there yet. Wait till they get up to 40 miles per hour and 1/2 inch size. We don't need the wall cloud or the shelf cloud reports, just the funnel clouds and tornadoes. Our system can monitor the lightning, so we don't need any lightning reports from you. And especially since people have started looking at the radar on their own on the internet, they like to call in what they're seeing to us, but that's okay. And then we do want to just mention that the spotter line, it's a 1-800 number that's on your handout there, is really to be used just for reports. We have another phone number listed on our webpage that we answer Monday through Friday. If you call in with any just plain old weather questions, you want to know about something, you want to know what the weather was on a certain date, or get a forecast for next week, we'd be glad to talk to you on that line. But the spotter line really is reserved just for making the reports. Okay, there is our spotter line phone number. It is going to be answered by a meteorologist 24 hours a day. You can also, if you're part of the Amateur Radio Network, you have your own resources there to make those reports. There's packet radio, and then if you want to become part of eSpotter, basically that's a way to go online and register to make your reports through the internet. And so if you're interested in that, and that is a great way to submit rainfall and snowfall reports, then you can go online and register for that. We do ask that you avoid using eSpotter for things like a tornado report, because what if there's a glitch in the system and we don't get it? So really best used just for the rainfall and snowfall reports for eSpotter. Okay, when you actually do make that report, we need you to tell us your location. So it really helps us if you start with what county you live in, because we do cover several counties, so that kind of helps us focus in right away. Give us your county, your city, and then you can even give us your location, like a major intersection nearby. Tell us what you're seeing. Tell us if it's a wind or hail report, if it was measured or estimated. and then the time of the event, and any damage that occurred with that. Okay, so a couple of quiz questions for you. If you look out the window and notice pea-sized hail starting to cover the ground, do you report it? No. Very good. No. Don't need your pea-sized hail reports. We start getting those reports when they reach a half inch or the size of plain M&Ms. Which of the following should you report? Very good. Funnel clouds. You notice cars are no longer able to make it safely through a water-covered intersection near your office. Do you report it? Yes. Yes. Any flood water that's impeding traffic should be reported. And you arrive home after an evening out to discover a tall pine tree in your yard has been snapped in half. You know there was a strong thunderstorm earlier. Do you report it? Yes. Absolutely. One thing you might keep in mind, though, is that maybe that tree was brought down by lightning. And so if you can notice, is there any sign of lightning? Is it dark colored around the break? Then that might have been from a lightning strike. But definitely call that into us and just keep that in mind as you're making that report. Okay, so we're going to take about a 10-minute break. If you wanted one of the glossy brochures, those are up here. Or if you didn't get a chance to sign in, please do that. Okay, I think we're going to go ahead and get started with the second half. It's not really the second half. The first half does run longer, so you don't have to worry. We're not going to be here all day. The second half's probably about, I'll try to get through in about a half hour or so we can get you guys moving out of here. All right, so starting off next, in the second half, we're going to cover thunderstorm evolution, a little bit on different thunderstorm types, tornado formation, a little bit more about water spouts, and then go through some more lookalikes with the shelf clouds, wall clouds, funnel clouds, tornadoes, so you can try to keep all that straight in your mind. So starting off here with thunderstorm evolution, before you can get any type of severe weather, of course, you're going to need a thunderstorm to develop. And so to get a thunderstorm to develop, there are a few ingredients you need. Those ingredients include moisture, especially moisture in the low levels of the atmosphere, and so you can tell when there's a lot of moisture when the humidity starts going up and it starts getting real muggy out. You need unstable air, and unstable air is basically air that's going to continue to rise once it starts to rise. This is a little bit of a tricky idea, but you can kind of think of it like how smoke would rise in a fire. If there's a lot of heat down low, that heat's going to rise up. And so on days when the atmosphere is stacked with heat at the low levels and cooler air up high, all that heat rises and it's considered to be unstable. The next thing that you need to produce a thunderstorm is some type of a source of lift. And that source of lift can be anything from a cold front to a lake breeze to even maybe gusty winds coming out of another thunderstorm. All of those are going to act as a source of lift for the thunderstorm. And then what you're going to get is what you're seeing right here is one of these nice puffy white clouds building up real high in the sky. All right, there are 3 stages to thunderstorm development. The first stage is the towering cumulus stage. And this is the stage where you've got these nice puffy white clouds going on. You've got all those ingredients that you need down at the surface, the heat, the instability, and the source of lift, and the moisture. And so you've got this air that's rising up into the cloud, which causes these clouds to get bigger and to grow taller. At this point, you don't have any rain falling yet. All you have are some of those nice puffy white clouds. And we say that the storm has an updraft, which is what it means when you have that air that's rising up into the thunderstorm. Okay, the next phase of the thunderstorm is where you're most likely to see that rain and possibly severe weather occur. This is the phase of the thunderstorm where you have an updraft that has gotten to be very strong, and it's causing this cloud to get much bigger. These thunderstorms extend up to 30 or 40,000 feet into the sky most of the time. And then eventually you have so much moisture that has condensed out of that cloud with that air rising into it that it starts to rain. And so with that rain, you have the hail falling from the sky, you have the winds picking up, you've got your downdraft winds, all of that stuff coming out of the storm at the same time. And so at this point, we say that you have your updraft both rising up into the storm and your downdraft, which is that combination of wind, rain, hail, all coming down out of the storm at the same time. And then in the next phase of the thunderstorm, we call this the dissipation stage. And this is the point of the thunderstorm where you see most of the arrows are pointing down, meaning that all of that rain and everything has come out of it. It might be still raining a little bit, but it's cut off that supply of ingredients you need that's feeding into that thunderstorm. And so at this point, all you have is the downdraft. You don't have any more heat and warm air rising up into that storm, and so the storm is starting to fall apart at this point. And it's starting to look a little less organized. You've just got a little bit of rain that's ending, your thunder and lightning are ending, and your storm is basically starting to fall apart. Okay, there's a few different types of thunderstorms that I want to touch on kind of quickly here, ranging from the single cell up through the multicellular types of storms, going up to the supercell, and kind of looks like they increase in intensity as you get over here closer to the red. And so starting off with your single cell, what you have at this point, if you remember that updraft that we talked about, feeding into your thunderstorm, providing the energy and the support you need to produce that thunderstorm. With a single cell type of storm, your updrafts are going to be generally pretty weak and they don't last real long. And so one of these single cell types of thunderstorms is only going to last maybe 20 or 30 minutes before falling apart and being done. With that, you do have a slight threat of severe weather. You can get some strong gusty winds or a little bit of hail, maybe a weak tornado, but this isn't going to be a real long-lived, strong producing thunderstorm. The next two categories of thunderstorms, both the multicellular clusters and the multi-cell lines, fit into the next stronger category of thunderstorms. At this point, your updraft's a little bit stronger, and so with that stronger updraft, your thunderstorm's going to be able to last longer. And with these multicellular types of storms, another reason they're able to last longer is because you have multiple updrafts. And so you don't just have the one updraft that can be cut off easily as that rain falls. Now you have multiple updrafts feeding into these storms that help to make them stronger and help to make them last longer. The multicellular types of storms can last sometimes for several hours before falling apart. And so these are a little stronger and a little bit of an increased risk of that severe weather with these storms. And then lastly, we have the supercell type of storm. Now looking at the picture, again, this is just one individual storm, but it's much bigger than we had with the single cell. And the reason for that is because that updraft that was feeding into the thunderstorm is much stronger. And it's much stronger because it's also rotating. And so this is your type of storm where there's a rotating updraft going on in this storm that is making it much stronger, and also the type of storm that's going to be most likely to produce a tornado. We're going to touch quickly on two different types of those storms that we just talked about. We're going to talk about the multi-cell lines, which are also called squall lines, and then we're going to jump back in and go a lot more into detail with the supercell types of storms. And so with the squall lines, which is what we had last year on June 8th, and it's the type of storm that's going to have one of those shelf clouds right on the leading edge of it. This is what you're going to see looking on the radar at one of these squall line types of storms. Similar to that radar loop I showed you before where the storm's tracked across the area, these radar images are from that same day, and there are the reflectivity images are the second picture and the fourth picture, which you're used to seeing on TV. The color curve is still a little bit different on here, but you still know where it's getting into the yellows and reds, where it is the strongest part of the storm. And the strongest winds are right on the leading edge of the storm again. Now, we also have a couple of different images up here for the velocity images that you might not be used to seeing. And what the velocity is it's actually letting us look at what the winds are doing inside of the thunderstorms. And this is actually what that term Doppler refers to. The Doppler functionality of the radar is what lets us see what the winds are doing inside of the storm, compared to just seeing where the strongest parts of the storm are. And so looking at the velocity on these images, right here along the leading edge, you can see where those greens are turning to blue. You can look on the scale, and that's where the wind speeds are approaching 60 to 70 miles per hour. And so they appear green as they're approaching the radar, and then once they move past the radar, which is right here on these images, the colors then turn to the other side of the spectrum, which is the reds and the yellows. And again, right on that leading edge there, you can see where the yellow is and kind of turning to orange. We have, again, those wind speeds increasing to 60 to 70 miles per hour. And so, using the radar and being able to see these wind speeds, Again, these wind speeds are off the surface at some level, 2,000 or 3,000 feet off the surface, but they give us a good indication of how strong the winds will be once they actually come down to the ground. Okay, again, about the squall lines, a lot of the time you will see that shelf cloud, which is that low horizontal cloud that stretches nearly across the entire sky. It's going to be a very noticeable feature. You can have wind speeds, again, up to 100 miles per hour with the strongest types of these storms. And you might actually even have the winds, again, rushing out ahead of the storm so that you're not being hit with any rain until as that storm reaches you or until it starts to move past you. All right, and then going on now to the supercell type of storm. These, again, are the most strongest and powerful types of thunderstorms and the type that is capable of producing tornadoes, or is most likely to produce a tornado. Now, I mentioned that it has one of those rotating updrafts inside of it. And so how do you get that rotation to start to develop? Well, if you're looking at this image here, and what you're seeing here is instead a couple of arrows showing wind speeds blowing at different levels in different directions. So let's say you have a wind at the surface that's kind of blowing out of the southeast, but then you have a much stronger wind some distance up in the sky that's blowing faster out of the west. Well, you've got those winds blowing at different speeds, and it starts to cause that circular motion in the horizontal, like that. Well, now at that point, once you already have that horizontal circulation, all you need is for that thunderstorm to move over top of you and cause that rotation to shift up into the vertical. And now what you have your updraft becoming one of those rotating updrafts and providing the strength to one of those strong supercell types of storms, which would be what would eventually lead to that tornado coming down to the surface underneath that rotating updraft. And we call that rotating updraft inside the supercell storm a mesocyclone. And that's the term that we use for that large, broad rotation that's occurring in this type of storm. Okay, this is a picture of one of these supercell types of storms, and I'm going to talk about a few of the different cloud features on here. Looking at this from the distance, you see this big white puffy cloud feature. That's the main storm tower. At the top of the storm, you have kind of a smooth ring around the top that we call an anvil. And what the anvil is at some point, that updraft is not going to be able to go any higher. It's going to reach some level in the atmosphere, 30, 40, 50,000 feet up, where it can't go any higher. When it reaches that level, then the cloud just kind of starts to spread out around the top like a ring. And so that's what we call the anvil. If it is a particularly strong storm, you might see one of these overshooting tops develop up here, which is really the storm's last attempt to kind of punch through that level in the atmosphere where it can't go any higher. If it does punch through it a little bit, you get a little more cloud sticking up on top. Okay, as this cloud approaches, you might have some strong winds come down to the surface, and preceding those, you might see something that would look like a shelf cloud. But you also might see that wall cloud, which was, again, that localized lowering underneath the mesocyclone in the storm. That rotation and that lowering right underneath that bigger, large-scale rotation in the storm. And these arrows kind of show you how all the air is moving in this storm right now. You've got your updraft feeding up into the storm. You've got your precipitation falling to the side. This is where your rain and your hail and everything is going to be coming down, your strong winds. You've got some more lift going on back here, and some more wind that's coming down here, which we'll go into more detail about when we're talking about how a tornado actually forms. Okay, so this is what this picture would actually look like if you're actually seeing it off in the distance. You've got your big storm tower, your anvil around the top, this puffy white cloud as the overshooting top. And then it's a little hard to see down here, but you would have some rain probably falling underneath this storm from the side there. Okay, now looking down at this storm, we were looking at it from the side. Now if we look down on the top of the storm, again we have right here in the middle where our rotating updraft would be. We have our precipitation kind of getting shot off to the side. And so this is where all of our precipitation's falling, with the strongest rain and hail right here and close to our updraft. We have all of the wind that's coming down with that rain and hail, causing some gusty winds to come along the front edge of the storm. We've got some stronger winds again also coming down, wrapping around the backside of the storm right through here. And we've got some different pictures showing where all of the different features would be, including the large hail right in here close to the center, the possible location of a wall cloud, and also the possible location of a tornado if it was going to develop right there in the middle. Now, if you were actually out there in the field trying to do some spotting work and the storm was approaching you, these storms are most commonly going to track from the southwest to the northeast, so it's going to be moving like this. And so as this storm is moving, if you actually wanted to see into the center of the storm to see a tornado, you're only going to be able to see into the middle of that storm in the area where the heavy rain's not falling. And so most typically with this type of storm, we have heavy rain just to the north of the updraft, north and wrapping around the west side. And you may have a break in the rain over here on the southeast side of the storm to get a good look into the middle and see if there's a tornado there. Otherwise, the tornado is going to be totally rain wrapped and you're not going to be able to see it. So if you're looking, this is the best place to view that tornado if you're out there and actually observing this. Okay, so this is what this looks like in relation to how it would look on the radar. Again, we have the heavy rain close into the middle here. That matches up with where the red is. Lighter rain around the edges. And we have that rain kind of wrapping back around here on the south side. And as that rain, heavy rain comes down, we have another downdraft. This is what we call the rear flank downdraft, and that's going to contribute to what causes that tornado to develop. You do see that this kind of has, we call this a hook feature, or a hook echo, and that's a classic feature that you observe when a tornado does develop, that hook signature. Here's another look of one of these supercell storms. Again, the heavy precipitation with that little hook on the bottom. And here's one of those velocity images showing us what that would look like at the same time. And if you're looking at this image, where the little picture of the radar is where the radar is located. And to interpret this type of image, anywhere where the green is occurring is where the winds are blowing towards the radar. Where the red is located is where the winds are blowing away from the radar. And so this is really the most helpful tool for us when we're trying to figure out if there's rotation in the storm and if it might produce a tornado. What we're looking for is this couplet, where you see the green and the red closely packed right next to each other. And that's because where the green and the red come close to each other like that, that's where you have strong winds blowing in opposite directions at the same time. Because again, you've got your winds blowing towards the radar and away from the radar. And so when you see those winds come together like that, that is where our rotation is in the storm. And if we watch that, and if we see that start to strengthen and start to get lower down to the ground, then that's when we would issue a tornado warning. Okay, so these are a couple more views of the supercell type of storm. You've got your big storm tower, nice anvil around the top. This might be a view from the leading edge of the storm, seeing those winds starting to pick up as that storm approaches. And one thing we kind of mentioned at this point is that we've been looking at the classical view of a supercell storm. And here in Michigan, we don't actually get that classic supercell storm real often. We get different variations of it. We get little short ones that might only reach 15 or 20,000 feet in the sky and tend to produce much weaker tornadoes. Or we get heavy precipitation versions of this storm, which means that instead of having that opening where you can see if there's a tornado in the middle, with a heavy precipitation version, you can't see into the middle because it's got so much rain with it. And so fortunately for us here in Michigan, these different versions don't produce as strong of types of tornadoes as you would see out in the plains. So these storms, when they develop out in the plains, have the tendency to be stronger and the more classical type of supercell that will produce that larger type of tornado. Okay, so taking a look now at how that tornado actually develops once you have your supercell. This is a great picture here with a rainbow in the background of a tornado there. So we look back at this top view appearance of this storm, where we have our updraft in the middle, air rising up right here, and then air coming down on this side with all the heavy precipitation, and then also coming down on the south side. All right. And we actually have that air rushing down on the back side of the storm. That is where the wind rushes down, and it actually causes some tightening of that updraft right there, which causes that tornado to kind of develop. And so looking at this then, with the actual picture of the storm, we have our wall cloud right here, underneath our mesocyclone or rotating updraft. We have strong winds coming down, wrapping around the backside of that storm, and as the wind comes down, it causes an extra rush of air up into the storm, leading to the formation of a tornado from this point. Okay, and this is a larger scale view of what it might appear like as that tornado develops. Again, you've got your mesocyclone right here, your winds rushing down from the rear flank downdraft, and that rush of wind causes that tightening of that circulation there, leading to the tornado development. Now, is it hard to get this to happen? Of course it is. We only average a few tornadoes every year, so most of the time it doesn't come together just right for that tornado to develop. But in just the right circumstances, that happens and the tornado forms. So here's a series of pictures of what it looks like as that tornado is developing. First, you start off with just your rotation in the cloud with your wall cloud. Then your funnel cloud starts to develop, but you still don't have any strong winds coming down to the surface. The rear flank downdraft comes down, your tornado develops, bringing the strong winds all the way to the ground. As time goes on, your debris cloud near the surface is going to get larger, and your funnel is going to become a little more tightly wrapped, leading to a mature tornado. Okay, a lot of our tornadoes, again here, we have the smaller type, and they may not exhibit that classic life cycle. And so these are a few pictures of some of the tornadoes that we have here in Michigan. This one looks quite unorganized, but again, most of our tornadoes are on the weaker end of the spectrum. Okay, going to talk a little bit more about waterspouts here briefly. There are really two types of waterspouts. People always want to know, well, is a waterspout just a tornado over water, or what is a waterspout? Well, there really are two different types of waterspouts. We have our waterspouts that form during our spring and summer months that are associated with thunderstorms that basically are just a tornado that tracks out over the water. Then we have our cool season waterspouts, which form usually in the late fall or late summer and early fall. And they form at the time of the year when we have a lot of strong cold fronts coming down over the area, and that helps to increase the instability over the water and leading to those waterspouts to develop out there on their own. So we'll go through those a little bit more here. When you do have your cool season waterspouts develop, one of the things that contributes to those is that your water takes much longer to cool off in the fall than your air temperature does. And so a lot of the time at night, you'll have a land breeze develop, which means the air is moving together, converging out over the water. And it's that convergence of those winds that will lead to those waterspouts developing, especially in a whole family like we saw in the last picture. These types of waterspouts tend to be a little bit weaker than the ones that are associated with thunderstorms. But they still have winds of 30 to 80 miles per hour, and something you definitely don't want to be hit by if you're out there on your boat. Now, the other type of waterspout, the warm season waterspout, is just as strong as a tornado. These can move onshore or offshore, and so you're never safe from a waterspout. If you see a waterspout moving to the shoreline, it doesn't just magically dissipate as it reaches the shoreline. So they do pose a threat and something to take seriously, just like you would a tornado. Here in the Great Lakes area, there are some regions that are more prone to waterspouts, including the Saginaw Bay, extreme southern Lake Huron, Lake St. Clair, and western Lake Erie. This slide is just mentioning that those waterspouts that form from those lake breezes don't move a whole lot. They tend to stay right there steady in the middle of the lake, and if you see one, you're going to have a much easier time getting away from it. Now, if you do have a waterspout that's associated with a thunderstorm, it's going to be moving just as quickly as that thunderstorm is. Thunderstorms can move anywhere from just a couple miles an hour up to maybe 40 or 50 miles an hour. So depending on what type of water spout it is, will depend on how fast it's moving. Okay, we've reached another section here to put you through some more tornado funnel cloud and wall cloud lookalikes. Again, when you're trying to find that tornado, you're looking for the debris cloud and the rotation around the vertical axis. So, what do you think? Is that a tornado? Getting a lot of no's. I know it's hard to tell, but there is no rotation there. And all you're seeing is just a distant rain shaft off in the field. How about this one? I know it's hard without it being animated, but it does actually have a small debris cloud down here at the surface. And it has a smooth condensation funnel, so it is a tornado. It's just one of those very long rope-like kind of tornadoes.
Yes.
Looks a lot like a tornado, but if you were actually there, you would probably be able to tell with some monitoring that it's not rotating. And so all you're seeing is the debris cloud from the rain and blowing dust from the outflow from the thunderstorm. Any guesses? It's not making contact with the ground, so we know it's not a tornado. And it doesn't have any rotation with it, so that rules out being a funnel cloud or a wall cloud. So all that is that scud, that low-hanging cloud hanging out underneath the storm base.
Yes.
This is a tricky one. We do see this feature right here. What's that? That's our wall cloud. But the debris cloud wouldn't be rotating if you could actually see it. So all we have here is the downdraft, the strong winds coming out of the storm, kicking up the dirt and the debris off the surface. And it just happens to be located from this angle like it's underneath the wall cloud. Yeah, this is tricky. I don't know if we meant to actually have this being located right over top of the smokestack. But it's not making contact with the ground, but it is rotating. So it's a funnel cloud. Very good. Okay, we're going to look again at the shelf clouds and wall clouds. Just a couple more images. Also introduced the roll cloud. We'll talk about that one here in a second, but again, the shelf cloud is that low horizontal wedge-shaped cloud on the leading edge of the storm. Looking at one of these squall lines, if you're looking at this image right here, this is one of those long lines of storm, so you can imagine that right here on the side that this extends out from the board all the way to the back of the room, and it's tracking that way. And you've got this shelf cloud feature right on the leading edge of the storm that you would see across the entire length of that storm cloud. It looks just like a line. Okay, so these are some more pictures of the shelf clouds. This is the shelf cloud here, the low horizontal wedge-shaped cloud on the leading edge. And I think it's just really a dramatic feature if you actually see it. This is a video. First it's going to play in real time, and so it's going to be kind of slow, but it is moving. And then next it's going to speed up so you can see the development of the shelf cloud. But you have your rising air here on the leading edge, your updraft lifting into the storm, and then your downdraft coming out the backside. Let's play that one more time.
Does this have an effect on the size of the hail,
Well, the
updraft and downdraft?
yeah, your stronger your updraft is, the stronger your potential for your hail to be. This type of storm, the squall line, is most likely going to have the very strong winds associated with it. It may or may not have some hail as well, but it's most likely to have the very strong winds.
It makes them larger?
The updraft would make the hail larger?
Yeah.
Yeah. Your stronger updrafts would lead to your larger hail sizes. All right, so what is a roll cloud then? If we've talked about our shelf clouds and our wall clouds, well, the roll cloud is basically when you have those strong winds come out of the storm, kind of rush ahead of the storm, and then they hit the ground. And from that point, what do? Well, they kind of get shunted back up into the sky. So strong winds come down, hit the ground, and then they kind of curve back up sometimes. And when that happens, it's almost like you've got this rolling cloud that appears to kind of come at you. And so as you're seeing this cloud is kind of out in front of the other cloud, and it's kind of got this circular motion to it as it develops. And so that's what a roll cloud is. Winds come down, hit the ground, and start to curve back up into the sky. And so that's basically what a roll cloud is, kind of also synonymous with those very strong winds that you would have with the squall line or with your shelf cloud. Okay, back to the wall cloud again, just to refresh your memory, the localized persistent lowering underneath that mesocyclone and the supercell type of storm. You see the lowering of the cloud right here underneath the cloud base. This is a video from the Flint area here from last year on April 11th, showing when their tower cam happened to pick up one of these wall clouds. So play that for you.
We have a viewer that is called near Flint Central High School, possible funnel cloud in that particular area. We do show some ominous clouds on a live picture from our Flint SkyCam, and why don't we just go ahead and show that at this point. Over the downtown area, we do show some threatening-looking clouds overspreading the downtown Flint area. We see this low-hanging cloud here. Certainly at this point, nothing that looks like a tornado there. The storm continues to overspread the Flint Cultural Center as we see the most significant area of rotation actually west of this particular area.
See how right in the middle there,
moving toward the downtown Flint
quite a
area.
bit from
I want
the
to
rest of
just
the
correlate with what
smooth
we're
cloud
looking at here on a live picture from our Flint SkyCam with radar.
If you do have one of these wall clouds, the longer that wall cloud lasts, the greater the chance that it could turn into a tornado. So if you're seeing one of these wall clouds, maybe the storm's not moving real fast, and you monitor this wall cloud for 10 or 20 minutes, that's an indicator that is a strong storm with a strong updraft and is more likely to end up producing a tornado. All right, so let's go through a couple more of these. Is this a shelf cloud or a wall cloud? This is one of the wall clouds because you've got just that lowering underneath the cloud base. The shelf cloud, again, is going to be on the leading edge of the storm and it'll really look like a line across the sky. So at this point, what can you expect? What kind of cloud is that?
It's a shelf cloud.
All right, so there's our shelf cloud. All right, so you're going to end up with wind at your face because you were looking at the shelf cloud. So if you turn around and run from it, then you're going to have wind at your back. So, all right. Just about finished. I just want to review for you everything we want you to report. Now that you're all trained weather spotters, we want any tornado, funnel cloud, or water spout reports, wind gusts over 40 miles an hour, any hail the size of a plain M&M or larger, which is about a ½ inch in diameter, any flooding that threatens properties or covers roads, rainfall of greater than 1 inch in 24 hours, any snow accumulations greater than 1 inch, and also any storm total snowfall at the end of the storm. Whenever you have freezing rain or sleet that starts accumulating on surfaces, And any other weather-related storm damage, anything. If it's the winter months and you've got strong winds producing damage to trees, we want to know about that. If it's the summertime from a thunderstorm, we also want to know about that. Again, to report, you can call that 1-800-SPOTTER line 24 hours a day, year-round. Somebody's going to answer that line. You can also submit your reports through your amateur radio network. I have been informed that the address up there for the packet radio is not correct. It's having some work done on it, and that's going to be changing, actually. So that is not the correct frequency. You'll have to get in touch with us later on. I'm not sure what it is. I apologize. And then also, you can submit your reports to eSpotter. And what we need to know again is where you're calling from. That's the best thing to start off with. Tell us where you're located, your county, your city, a major intersection nearby. Then tell us what you saw and what time you saw it at. And then also tell us if your report was measured or estimated. All right, do I have any questions out there? Okay, Greg was going to come up here and say just a couple of words. All right, I do really want to thank everyone for coming out and attending the spotter training. You guys really do provide a great service to us and to your community through this process, so we really do appreciate your help.
Thank you.
Okay, my name is Greg Ibarra. I'm the emergency coordinator for Genesee County Areas, and we'd like to thank everyone that did come. Oh, we got a question back there?
Move that way, Linda.
Okay, we got, anyways, we got, one of the things that we wanted to do is thank you for coming out. What we wanted to do is find out how many people here is from the general public, if you just kind of raise your hands. Okay, and how many people are from the public service agency, fire department, police agencies and stuff? All right. There has been some questions about having people wanting to take ham radio classes. We have a sign-up sheet on your way out on the corner of this table. It's also going to be starting April 22nd. I thought it was March, and I told a few of you that it was going to start in March, but I checked on it, and it starts April 22nd. It runs for 5 weeks, and in the 6th week, they'll do the test. So it costs $30 for the test. If you want to go ahead or $30 for the class, that includes the book. So if you want to go ahead and sign up to be a ham radio operator, just go ahead and sign it in. Sign up there, give me your name, email, and phone number, and what I'm going to do is take that information and send it off to the lady, her name's Amy, the one that's going to go ahead and do the class, and she'll get everything all set up so you guys can go ahead and take the class. Once you take the class and become licensed, because you're already a trained spotter now, you would be able to assist during any SkyWarn activations. Okay, with that, what I would go ahead and do is we're going to take about a 5-10 minute break, and everybody else, is kind of excused. And the people that I want to talk to now are going to be the ham radio operators, because I have to go over a few things of our net procedures and stuff that we're going to be having. So again, thank you for coming, and thanks a lot for caring.
Thank you.